Okay. Hopefully this will record, and then I can upload it later. Come on in, and then we'll be able to help others. Come on in, who are late or who are perhaps missing the class. So the first order of business is to introduce myself. I'm Professor Lyon. I'm the, come on in, the chairman of the Electrical and Computer Engineering program. Come. More the merrier. And you are in SW407, Java for Programmers. If you don't want to be in SW407, Java for Programmers, you should leave because you're in the wrong class. But if you want to be in it, you're in the right place. One of the things I have been doing lately in courses like this is I have been using a course management system, what some call CMS, Course Management System. And the one we use here on campus is called Blackboard. A show of hands, please. Who has heard of Blackboard? Only a few, not everyone. So it's something you need to learn, and this is how we give out the work and how we collect the work. So we have to log in to the Blackboard system with our user ID, and then we have to select the course in order to be able to read the homework and then submit the homework. So it is very important for a class of this size to go through the Blackboard system when submitting it. I would not accept someone saying, "Oh, here, professor, take my homework and just hand it to me," because we're all going to go through the Blackboard system. And what I'm going to do is I'm going to review with you the Blackboard system now, since some of you are new to the Blackboard system, and we'll all get around a lot easier if we can go and submit our work electronically. The course syllabus is on the Blackboard system. I've taken the liberty of downloading it, but I'll show you where it's located. The course syllabus has a textbook associated with it. It's really the best textbook available in the field, and I can say that because I'm biased. I wrote it, so it must be good. It's a little bit confusing because after I wrote this book, Java for Programmers, somebody copied the title. And so what they did was they call it Java for Programmers by Dytel. That is the wrong book, not the best book in Java. So apparently they liked my title so much they just copied me. I couldn't stop them from doing it. Too bad. The book is available online. It is from Amazon for a little under $10. I think maybe I don't have a copy with me, but there is. You can also buy it used for a little over $10, and it comes on paper. And if you need a new copy, I have some new copies available, but it's $25 for new copies. The online copy is just as good. You can read it with iPad or Android or Kindle or just on your computers. So that's just fine having an online copy, I think. In the course, I will come to the class early. My goal is to be here in this classroom an hour before class begins so that you can come for extra help. Also, I will stay after the class is over to have office hours with you. I have another course. It is called ECE 508, Engineering Entrepreneurship. Show of hands, please. Who is in that class? Oh, Oh, look at that. Oh, very good. So I'll see you again. Interestingly enough, the class was scheduled on a Thursday evening. We now have over 50 people in the class, and I am told there is no room for us. So I said, well, you have to have a room for us, because what can we do with the students? Send them back? Right? Come on in. So I thought, well, we'll find a place. And so what we did was we negotiated for a room, a big room that could hold 60 in the Dolan School of Business, because it's a nice business course. And there's a small change. And the change is, it's not Thursday evening anymore. It's Sunday afternoon. Is that terrible? It is? Oh, I'm sorry. What could I do? I don't like teaching on Sunday afternoon either. Believe it or not, I have other things I would like to do on a weekend. Imagine that. But still, I enjoy teaching, and so I think it's very good to teach during the day when people are fresh on a Sunday afternoon. And it is perhaps, I don't know, a couple and a half hours out of your life. I will be there an hour beforehand at noon on Sunday in that room. Bells and whistles on, playing with my computer, waiting for students to show up early if they would like to come. And that will be my office hours for that class. I will also stay late after the class on a Sunday to meet with you if you need to see me. The other hours, which I have listed here, I will hold in my office in Banau 112. So now there are 3 different places that you can find me for office hours. Sometimes I will be here, sometimes in Dolan School of Business on a Sunday, and other times during the day in my office. So they got me all over the place. What can I tell you? I am literally from this side of the campus to the other side of the campus. So if you find me hard to find, this is why. And now you know why. I have call forwarding on my office phone so that people can find me, because I won't be sitting there in the office waiting for it to ring all the time. Leave a message. Very important. Let it ring. Leave a message. It takes a while to come through, but eventually it encodes your voicemail into a file and sends it to me by email. So that's a perfectly fine thing for me, because then I will eventually get the message. Don't forget to identify yourself when you leave a message. Oh, Professor, I called you. Please call me back. Who? Who called me? How do I call you back? Right? Because when the voicemail is encoded into a file and sent to me by email, what they don't send is caller ID. So I don't know who you are. You have to tell me, and don't forget your number. Because, hi, Professor, I called you 3 times and you don't call me back. Don't you like me anymore? Yes, I think you're fine. I don't know who you are, but I think it's okay. Just leave a proper message. So, if I'm not returning your calls, there might be a reason for that. What I plan to do this semester is cover at least the first 15 chapters of the book which you don't have yet, but which you will get. I have grading policy in the course. Homework counts a lot. Homework counts 1/3. The midterm counts 1/3, and the final counts for 1/3. And the homework assignments are done at home by you, not by your friends, not in a team. You have to try your homework. So it is very important that you do the exercises to get the benefit. You can watch me program all day long, and maybe it will make you tired, but you will not get the benefit. It's like watching me do sit-ups. Right? Boy, that Professor Lyon, he works hard doing his sit-ups. But your stomach will not get tight if you don't do the sit-ups. Right? So if you want the benefit, you have to do the exercises. So that's very important. Let's see what else we can say. Homework assignments are due when they're due. So what I do with the cutoff date on Blackboard is I have you submit. You submit once and only once before the deadline, and I set the deadline for the homework. And for the next homework, homework number 1, it is due at 11:59 p.m. on Tuesday, just before midnight. That's when I set the assignment to be due. So please do not wait till the last minute to do the homework. It is some 10 points per day late. It's always better to do the homework on time than to wait because it's not quite working yet. And now I would open the floor to questions. Are there any questions? Oh, you're so quiet. What I would like very much to do is to set the ground rules for the course. If you have some question, don't hold your suspense. Don't hold the question in. Just belt it out. Just say, oh, Professor Lyon, could you explain this? Could you go over that again? That if you're asking that question, chances are good 4 or 5 other people have the same question and they just haven't given voice to it. I'd much rather have you give voice to your question immediately than to hold the question. So don't just stand on ceremony. Don't just raise your hand and wait for me to recognize you. Just belt it out. Professor Lyon, help me out. I can't figure out what you just said. And that's fine. Interrupt me. I love it. Ask questions. Lots of questions. Are there any questions?
No.
Thank you. So now, what I thought I would do, just to try and maybe get to know you a little bit, is practice my pronunciation. Abhinav. Here. Mithun. Mithun, you're here. Kushik. Say it again. Kaushik. Uh-oh. Miranalini. No? Raul. Raul Badam. No? Abhina Dan Reddy Badam. You're here. Help me with the pronunciation, please. It was excellent? I don't believe you. All right. Okay, sorry. Sanjay Reddy. Here. Punya Venkata? No? Rakesh? Akhil? Here, good. Praveen? Good. Rijoy? Naveen Kumar? Thank you. Vinay? Thank you. And Hari Krishna. I've heard this name before. You're a very famous person, no? Mukit. No? Prashnant. Say it again? Prashant. Thank you. Dinesh. There's more than one Dinesh. I got Dinesh Mankonda. Thank you. Sindhu. Thank you. Ashrith. Ashrith Reddy. Mo Reddy? No? Okay. Sruti Reddy. Here. I lost my place. Oh my, there's so many. Bhargava. Thank you. Vashali. Pradu. Yashwant. Thank you. Surya Vamshi. Surya Vamshi. Raja. Here. Rajendra. Thank you. Come on in. It's the missing people. Come in, come. I knew there was more. Shravan. Here. Akali. Or Akala. You're here. Okay, thank you. Nirharika. Nirharika? Kishan? Vidya? Vidya. Sai Vinata? No? Swathi Suri? No? Who didn't I call? Uh-oh. What's your names? Sai, is it Sai Vin? It's not this one. Huh. You sure you're in this course? Okay. Who else? Vinish. Vinish. Did I skip your name? What's your last name? I don't see you here. Who else?
Rakesh.
Rakesh. What's your last name? I don't see your name. It's not there.
3938.
Oh, you mean you're going by the number?
Yeah.
I can organize by student ID. Sort ascending. What's your student ID?
380. Last one. Yeah.
Oh, here it is. Rakesh.
Yeah.
That's you? Okay.
372. Top up. Above.
Oh, I see. It's Punya
Chandrala.
Chandrala?
Chandrala.
Chandrala. Good. Yes. 542. Do you see your... I'm scanning the list real quick and I don't see it. Do you have... What are the first numbers? 0013?
0013.
Uh-huh.
954.
9 5. I don't have 954. I have 001394. Is it possible you're not in the right place? Not on my list. Yes, sir. And what's your student ID? 0013 751. I'm sorry. I don't see you in my class. I think maybe you... is the other classroom 106? Banau 106?
Maybe.
I think so. I think you two may be in a different classroom. I'm very sorry. They moved you. What a mess. My apologies. Anyone else whose name was not called? Okay. I guess you're in the right place then. So what I wanted to do... geez, what a way to spend the beginning of the class, right? And the new semester. Terrible. Everybody got moved around. I must tell you that I anticipated that they would cancel the other section and just do everything in one big section. But instead what happened was the dean decided to take the big section and split it in half. So what he did was he cut the baby in half. And I said I would be very happy to take on Dr. Yu's students and he could teach something else he enjoys. I don't care. Maybe give him a course off. But the dean wouldn't hear of it. Now, so this is this is the outcome. I'm very sorry. Let me introduce you to more students. Come on in. Let me introduce you to more students. Come. I beg your pardon?
We have to check is our name is here.
You have to check if your name is here.
Yeah.
Okay, what's your student ID? You can see it from here, I think.
Surname P-O-N-O-G.
You want to do it by surname instead of student ID?
Yes.
And it begins with a P?
Yes.
Your name is here?
Yes.
What's your name?
IACT20140903.
So it's right here. That's your name? Okay, great.
Mine is Niharika.
This one?
No, down.
This one? This one? This one? Ah, it's, say it for me?
Niharika.
Niharika. Niharika. Okay, thank you.
Mine is Vaishali. It's there with on double 0
Okay. Say your name again?
Vaishali.
Vaishali?
Yeah.
Vaishali. Okay, so the V is pronounced Y. Okay, thank you. Down a little bit. SA. I'm doing this by last name. So you're coming. So your registration's just a little slow. Is your name here? With a V?
Yeah. S-A-I. Yeah, I have.
You're here?
Yeah.
Okay, great. Yeah, look, if you're not registered officially, but you're going to come in, that's fine. So we'll expect to see your paperwork soon. Thank you. All right, so, we're going off to a very slow start here today. I'm very sorry for that. You know, there's lots of room down here. You don't have to all crowd up there. He's feeling terrible. How come you're moving? All right, so what I plan to do this semester is cover the first 15 pages of the book. When you go to the course content in Blackboard, after you log in, you will find that I have uploaded lectures in PowerPoint. They come in as a zip file. I also have a pointer to the book. And if you click on this URL, it will take you to Amazon where you can actually purchase the book. I think. Yes, and there it is. So this is the Kindle edition of my book. If you are interested in something not the Kindle edition, if you don't like electronic books, Kindle edition works for iPad, Android, Kindle, of course, and the laptop or the desktop, the regular computer. You can find I've been infected with adware. It's terrible that it does this. So if you get out of this Kindle store and go to books and say Lion Java for Programmers, you can find there is a $10 version of the book, although that won't last. If people want the paper copy and they want to spend the $10 for used, they can, but I have a feeling it won't last. And then for under $10, you can get it electronically. And new is available too. And also, if you want, you can get it from me for a similar price. I think $25 new, delivered hot and fresh into your hands. So there's a, oh, here's the Chinese edition. I had no idea. How could there be a Chinese edition? I didn't write it. Someone else has translated it, I think. I never, oh, Java Programmer's Guide by me? How is this possible? And look, here's someone is charging $231. I don't get that money. I don't know who gets that money, but it isn't me. Someone. I'm shocked to see my book has been translated into Chinese. I will have to look into that. Maybe this is not a proper copy and I have to get Amazon to try to remove it. In any case, that's the book. You want the Kindle edition, I think. And then I have created a thing here called Homework 1, which is due at 11:59 on Tuesday midnight. And Homework 1 you can submit through Blackboard. And these are homeworks directly from the back of the book on Chapter 1. So it would be very good if you read Chapter 1 before you did the homework. And in fact, the first thing it says in the homework is, please read Chapter 1. So I think have a reasonable expectation that people will read the book. And so this is what I'm hoping everyone here will do. And in fact, I have these questions that I got from the back of the book, and then I have a little homework assignment. Type in and debug the following code. What is the size in bytecodes of your class file? What's a class file? Very good. Nobody knows? Really? Has anyone ever had a Java course before? No Java courses. No, never? Really? Oh, how about that? So, first thing you would do, if you've never had Java before, is you would go to I'm afraid to type anything into Google because I'm so badly infected. Every time I open up a window, it asks me if I want to download some malware, which is really very terrible. So what I will do is I will close out my Chrome and try to run a different browser, which I think is not infected because I just installed it. And what I would do here is go to Google. Hey, come on in. And I would search for a Java Development Kit. Now, Java Development Kit contains many interesting and wonderful programs. It contains, most importantly, a Java compiler. Java Runtime Environment does not contain a Java compiler. Java Development Kit is what you need if you want to develop Java programs. The other thing you want to find is the version called JDK, Java Development Kit 1.7. So if you say Java 7, download for, and then on my system I have what they call Windows 7. Some people have other things, Windows 8. I don't do Windows 8. I'm skipping Windows 8. I skip Vista too. You know, every once in a while Microsoft has a miss, and I just say, we're not doing Vista. So I go to Windows 7, and I happen to have a 64-bit machine, and I think most everyone here, if you decide to get a laptop and bring it to the class, you will have also a 64-bit machine. And I'm going to get my download straight from Oracle. Oracle took over the Java development from Sun Microsystems when they purchased Sun. And so when you go to get Java, you must get it from Oracle. And so for your Java Development Kit download, you can see there are many different platforms. I placed one of my students who was in here earlier today, chit-chatting with me, in a company called NASDAQ. NASDAQ is a company that's responsible for trading on the financial exchanges here in this country. They have many software developers that work here in Connecticut. And so one of the things that he was telling me is they started to use C#, and he says C# is much better than Java. And I said, well, is C# portable? And he says, no. I says, well, then how is it better? He says, I like it better. He says, okay, that's different. So here you can see Java is available for Linux, for Mac, for Solaris, for Windows, plus there's Java on all these different wonderful platforms that you can get that are embedded, such as every Nokia cell phone runs Java. So there's Java in a lot of different places. So what I can do, and I can even get Java, oddly enough, to run on my iPad. So I have to hack the iPad because Apple has practically outlawed Java on the iPad and the iPhone and the iPod and all the everything that Apple has. But I can still run Java there. I just have to run the little hack that lets me do it. So what you will do is you will click on the appropriate install. And if you get the wrong one and it doesn't work, don't blame me, because I told you to get the appropriate install. So that would be, for me, the 64-bit version of Windows. Once you run that installer, you should be able to open up a command line interpreter prompt, CMD, right? Some people call this the DOS prompt. DOS prompt? What's DOS, right? Do we still have DOS? You all know what DOS is, right? So if I type, for example, after the install, my goodness, Java minus version, what could possibly go wrong? What is it thinking? I don't know what it's thinking about. That should have come back right away. But in any case, it tells me what version I'm running and verifies to me that I have JDK 1.7 installed. That's very important to me because if I don't know the version that's running, I can't know that I have the latest version that's needed for this class. There's another thing that people might like to do. You might like to know where the Java is installed. And so what I would do in a case like that is show you under Windows. Is it Program Files? Maybe it's this way. Program Files. There it is. Java. So it's C:\Program Files Java bin. No? It should be in here. Here it is. JDK 1.7. I have more than one version installed, so it's a little complicated. So I need to get to the right version and then go into the bin. And now I have, this is where they store the exe files, which are a part of the Java Development Kit distribution. Here we in the biz, in the Electrical and Computer Engineering Master's Program, call it the JDK distro. Distro means distribution. And so then if you say dir, you can see everything in the directory, fills the screen and goes off the top. If you say dir and use a vertical bar, that's called a pipe. It takes the ASCII, that is the text, from the dir command and pipes it into another command called more, which lets you see one screen at a time. And then you can see where it says more down in the lower left. See that? Yeah. So now you can see some things here. Java commands, one screen at a time. The applet viewer, a jar command, a jar signer, javac, that's my Java compiler, Java, that's the name of what's called the Java virtual machine. So what you do as a Java programmer is you write Java source code, you save it to a file, then you invoke the Java compiler. It takes the source code that goes in, and then it outputs the compiler output file, which is called the bytecodes. Bytecodes are called bytecodes because there are only 256 different bytecodes, and they represent 1 byte in a virtual machine which is known as a RISC machine. RISC, what does RISC stand for? Good, yes, Reduced Instruction Set Computer. What does CISC stand for? Complex Instruction Set Computer. Thank you. So the RISC machine that is represented by the Java virtual machine is run as an interpreter or a compiler. The virtual machine, when it runs as an interpreter, takes a very small footprint and can fit inside of a microcontroller, an 8-bit toaster controller, if you will. An 8051 can run a Java virtual machine interpreter slowly. Or you can compile it in advance using what's called an ahead-of-time, or AOT, type compiler that gives you exe files directly. Or you can take the class files and you can compile them just when you need to. And that's called JIT, or just-in-time compiler. So most of the time, when you, as Java programmers, run your code, you will be running using the java.exe command that's got a just-in-time compiler built in. And it will take those bytecodes and compile them down to the underlying iron, which in my case is a 64-bit Intel processor. So in order to optimize the code, you need some kind of a compiler. Otherwise, you run it as an interpreter. Moreover, it's very good if you can target the underlying iron, they call it, which is the hardware. And that's what the just-in-time compiler does. You pay for that. You pay for it in terms of time. It will take time to compile the code when you first start. But after you run it a few times and you've warmed up the just-in-time compiler, it runs faster and faster. So Java is a little bit different from code that you're used to because of its non-deterministic runtime. When you do just-in-time compilers and you benchmark, you're actually benchmarking the compiler. This is so important. What is going on? I'm getting adware. I've been infected with malware. I'm running something to scan for it in the background now. Windows gets infected so quickly. Isn't it terrible? So what I thought I would do is introduce you to this basic idea of the path. Does everybody know what I mean when I talk about the path? In a command line interpreter, you run a loop, and the loop reads the text that you type, then searches through the command line path and tries to find the class. If it can't find the class, it gives you an error. So, for example, if you type wow, it says, I don't know this command. Right? There is no wow.exe. But if I type Java minus version, he knows the command because dir java.exe is there. So what you want to do is you want to make it so that every command in your JDK directory is part of your path. When you type path, if you read through the path, you should be able to find something that says program files, and here's the JDK. Right down through to the bin directory in the path. So that path has been established inside of your environment. In order to be able to change the path variable and make sure that that path is in your environment, you can edit the path by first taking the path from here. Let's mouse right, mark, click to the left, click down to the right, and hit enter. That puts it into the clipboard. Then what you do is you go into your control panel you look for the system control device. Under Advanced System Settings, go into your environment variables. And what you will see as one of your primary environment variables is called the path. There's the path. You can now edit your path. And here, sure enough, last thing on the path is the JDK. Now, if you wanted to wipe that out, you could paste in what was in your clipboard. And that puts it in your path for the next time you open up a command prompt. That means that you'll be able to find the Java compiler called JAVAC, J-A-V-A-C. So JAVAC is here in the present directory, but if I change directories, it's still able to find JAVAC. Why? Because it's in the path. All of your environment variables can be settable by you, and you can see all of your environment variables if you just type set. And then you can list every environment variable that you have. You can set the environment variables directly in the command line, but they'll be reset next time you close the command line interpreter and reopen it. The only way to change it permanently is to go into the environment variables under Advanced in the system control device. That will change it permanently. Got that? Who's lost? No one will admit it. So if you have an idea that maybe you'd like to write your first Java program, let's make a directory called hello. We'll make another one. Make a directory called SW407. That we don't have. And now what I'll do is I'll write my first Java program. Java programs that have classes in them have to have files whose names match the class. So if you want to write a program whose class is called hello, then you want to start with a file called hello.java. I will use the worst editor in the world because everyone has it. What is the worst editor in the world? It's Notepad. So Notepad, hello.java. Notepad. And it says, so you want to create a new file? The answer is yes. And so now we've got a new file, and we'll just write our very first Java program. Public class hello, public static void main string args array system.out.println hello world. Got that? Am I going too fast? And then we close the braces and we hit save, and that's it. Now let's see what happens underneath the hood. It says hello.java. If I say type hello.java, what do I get? What I just typed. Looks good. I think it's got no bugs, but there's only one way to tell. JAVAC hello.java. Works. So now I can say dir, and I can see, aha, it created a class file. That consists of the bytecodes. Those bytecodes represent the output of the compiler. So the compiler input was hello world source code. Compiler output is bytecodes. Are we done? No. No, we have to run the program. It hasn't run yet. So now we have to invoke the Java virtual machine to dynamically load the bytecodes at runtime and then execute the bytecodes after running them through the just-in-time compiler of the Java virtual machine. Could this be any more complicated? What could possibly go wrong? Java invokes the Java virtual machine, as opposed to JavaC, which invoked the compiler. And it prints hello world. So now, we've run our first Java program. What do you think of that? Now who's lost? Nobody. Really? I did good. That's good. So perhaps it makes sense for us to go through an analysis and see what it is we just did. First of all, what is the point of having something that's called public? What is that? What is public? Yeah, everyone can access it. Public identifies the accessibility of the identifier hello as a bytecode class that anyone can load and anyone can run. Class is a grouping of data structures and algorithms all together into a single thing which people call an object. Yes, that's an object. And so then hello, the name of the class, that's clear. Public we saw before. What is this thing about static? What is up with that static thing? What does it mean? There's two things you can have, static or dynamic. So if it's static, it's constant, it's available at runtime or compile time. Which one? Compile time. So static constants are allocated inside of the bytecodes. So if I have a static array that's 64 bytes, guess what? My bytecodes just got 64 bytes bigger. If I have a static image that's a megabyte, guess what? My bytecodes just got 1 megabyte bigger. But if I have to dynamically allocate the data structure at runtime to hold a whole image that's a megabyte, well, that might slow me down a little bit. So maybe I have to trade off. It's pay now or pay later. That is a very common theme in computer science. Pay now or pay later. So with dynamic allocation of memory at runtime, you could have a memory unavailable error at runtime. That's called a dynamic exception. If, on the other hand, you have statically allocated, then you don't have to worry about these things not being available at runtime. But your bytecodes will take longer to load by the dynamic loader, because bytecodes have to be loaded by the Java virtual machine. The bytecodes have to be compiled by the just-in-time compiler. So there are these trade-offs that you need to measure when you are a programmer. You keep these things in mind when you're programming. Not now, but later. We'll see that they matter. What else do we got here? Oh, string args this. What is this? String. I know what a string is. Characters. Yeah, yes. It's Unicode, 16-bit, unsigned quantities. So these are called characters. They come into an array called args. The size of the array we don't know, but apparently we can find out somehow. And then we have this other thing here, system.out. What is this dot business? What does that mean? Dot. System is the name of a class. Out is a variable that resides in the system class. print line is a method that's being invoked in the out variable in the system class. And the argument to the out variable apparently is some string, hello world. So if I said to you, well, that's very interesting, what would happen if I wanted to know how many arguments there were, args? How could I know the length of the array? Any ideas? An array is a data structure. It's a data type. It holds a list of things. And arrays are interesting because each data type in the list is the same as every other data type. It is called a homogeneous list. So if we were to try and do something with the list, maybe it would make sense to print out something like how long the list is. System.out.println. Let's see now. Length, colon, end quote. And now what we'll do is we'll use our plus sign to concatenate a string. Plus sign, args dot length, n paren sem. Well, what did I just do? Plus, I know what that does. That adds numbers. But here, I'm not using it to add numbers. So plus is an operator which takes two arguments. That's called a binary operator because it takes two arguments. But it's not actually adding numbers. It's taking two strings and putting them together. Right? That's called concatenation. Yes, concatenation. So we concatenate length, colon, with the integer args.length, convert the integer into a string, and make one big string which gets passed into the print line that then gets printed. What do you think of that? Length of the number of arguments, right? So now let's save it. Let's go back to our little program, javac hello.java. Couldn't this work? Now we type java hello, and it says the length is 0. What if I said java hello, this is an interesting test. Aha! The length is 5. Why is it 5? Well, let's see now. 1, 2, 3, 4, 5. I see 6. But hello is the name of the argument. So maybe there really is 5. 1, 2, 3, 4, 5. How's that? So somehow args, the array, is actually passing the arguments on the command line into the Java virtual machine and giving us accessibility to the internal workings of the program by allowing us to pass in parameters. How's that? Pretty good, huh? So now, what can I do with this array now that I know that I can access its length? I seem to be having issues. Here, get out of that. Click on this. There we are. Suppose I said to you, this is very interesting. There must be elements in this array. I should be able to access them. How do you think I could access the first element of the array? I'd like to print it, right? So maybe I could put in a print statement. System.out.println. I guess I could put in quote args of 0, end quote, oh, maybe I need a colon here just to make it nice, plus args of 0. See what that is. So that'll be the first element in the array because Java, like C and C++ and C#, starts numbering its arrays at 0. Mathematicians and Fortran programmers start numbering their arrays at 1. So let's see what happens if we save it. I use the up arrow to go back. That way I can type less. And it says array out of bounds exception in line number 5. So he doesn't like, oh, I know, he can't get to the first number because there's no arguments. That's a good test. This is a test. And the first thing was this. So he couldn't access it without any parameters. So that's fairly key. So he got the first thing. And probably I could get the last thing. If he starts at 0, and 0 is this, is 1, we have what, 3? Yeah, we have to go from 0, 1, 2, and 3. That adds up to 4 as our total length. But maybe we can list out all of the arguments in a more elegant fashion. Suppose I don't know how many arguments there'll be in advance, and I want to write some kind of a loop to gain access to all the arguments and list them out to the screen. How would I do that? Have you never heard of a for loop? Yes, I think so. So I will do that with an iterative structure. I think I can write a for loop. I'm going to start a little bit slowly. I want to write a program that counts to 10. That sounds really hokey and stupid, but I'm going to do it anyway, just because I think it's very good to see a program that counts to 10. So I start with a program that says hello world, then I go to a program that counts to 10, and after that all the rest is easy. So I'll write a program that counts to 10 for integer I equals 0 while I is less than 10, I plus plus, and then I think what I would like to do is I will print I out to the screen. Let's see if this works. System.out.println, and we'll print I colon end quote plus I. What do you think of that? What did I just do? Well, let's see. Yeah, I becomes a local variable, which is of data type int, which makes it a 32-bit signed quantity. While I is less than 10, and then that's a condition that terminates the loop. And then increment I at the bottom of the loop. So we start I with 0, and we work our way up to 10, and the loop will terminate. And I expect this to print 0 through 9 and then stop. I think that is a reasonable expectation. Aha! So I can count to 10. The crowd is wild. So now what I'd like to do is count up to the total number of elements in my array, which I happen to know is called args.length. And then for each element in that array, I'm going to access it using element I. So I will write out quote colon end quote plus args of I. And now what that does is it enables the index I to access the list of arguments, so that no matter how many elements are on the command line, this will grab those elements and print them out one at a time. So if you can count to 10, you can count to as many elements as are on the command line, presumably more or less than 10. What could possibly go wrong? I was trying to get back to my... I don't want to have to type everything. So there it is. That's what I wanted to do. Now who's lost? No one? So do you think you could go home and write your own Hello World program and type it in and compile it and make it say Hello World? Remember, you have to do the exercises to get the benefit. Okay. So one of the things that I like to do when I do a programming class like this is I like to have a little bit of a discussion about why. Why are we doing this? How come this, how come we're here in this class? And what do you guys think you're doing putting a whole bunch of real hardcore hardware engineers into this software class? What's up with that? Right? That's a legitimate question. So let me say this about that. Without software, the hardware is useless, literally useless. Moreover, if you go into the world of industry and you have to build hardware for people, almost always it has value added when there's a computer available. So even if you're a hardcore electrical engineer working in power distribution, guess what? Everybody has smart meters. Everybody has smart grid. Everybody wants to do stuff that allows them to connect in the last mile to the meter and read it so that they don't actually have to go there with a guy to actually write everything down. They want it automated. It makes people more productive. It allows people to sense where the faults are in the power line and fix them more quickly. It allows people to do micro power generation so that if the wind dies down, they can fill it in with solar or instantly power up a steam boiling water reactor. They have all these interesting and wonderful applications for, I'll call them microelectronics, smart microelectronics embedded in the power system. So we, as modern engineers, add value because we bring these skill sets to the table. When the legacy power guys don't know anything about computers, we can bring in the microcomputers and add the value. So this is a key element, being able to do some programming and not being afraid of it. If you want to do something, let's say in Danbury with the Hologic crowd, they hire people to do 3D digital mammography. You need computers for that. That's biomedical imaging. You want to go over to the Covidian crowd. You want to do the next generation diabetic measurement system. Google has a contact lens that measures your sugar level in your blood. This is so important because some people are not very compliant with regard to their insulin when they're diabetics. There are all kinds of applications for the Internet of Things where people are starting to do connectivity. We have several projects like this today. So when you think about, for example, the smart bit, or the Fitbit, where people have like a fitness watch and it communicates to the Bluetooth how far they've walked, these are, I would call them, value-added things that, well, we don't normally think of as so important. And yet, nowadays, I think they are. They're adding value, and they're building wealth. They're allowing us to create wealth. Is it warm in here? No one else is warm? I'm the only one? Somewhat warm. It's warm. I'm going to do something about it. Just a minute. Yeah, it's 80 degrees in here. Pushing the button doesn't work. What can you do? So I have these basic ideas about teaching Java, and I think it makes sense for us to do something of a little bit of a review on what I would call the primitive data types of Java. Primitive data types. Primitive data types of Java are grouped in integral exponents of 2. There are 8-bit quantities, 16-bit quantities, 32-bit quantities, and 64-bit quantities. They are all part of the primitive data types in Java. What would be an example of an 8-bit quantity? This is Java for programmers. If you had a group of 8 bits, what would you call it? A byte. Sure, it's a byte. The next one up is 16-bit quantities. For numeric 16-bit quantities, you have what are called floats and short. For numeric 32-bit quantities, you have what are called double and int. For numeric 64-bit quantities, you have what are called long. Okay? So I like to think about Java in branches. There are two different kinds of primitive data types in Java. They are numeric and numerical and non-numerical. Numerical and non-numerical. There are two different kinds of numerical data types in Java. There are fixed point and floating point. There are two kinds of non-numerical data types in Java. Boolean and char. Boolean has two different values. It is either true or it is false. I'm a computer engineer. Therefore, everyone in this class either gets A or F, because there can only be two different possible grades. No, that's not true. So for char, in fact, it is an unsigned 16-bit quantity called Unicode. In Java, what that means is you can represent 2 to the 16 or 65,536 different possible symbols in any given font. This is a very compelling thing because certain languages represent words with pictures. These are called ideographic languages. Like, for example, katakana from Japan is an ideographic language. They have many different characters. So to be a truly universal code, you need lots of different characters in a given font in order to make your language programming universal or portable for the different languages. So char is 16-bit unsigned. So, two different data types in Java, numerical and non-numerical. Two different non-numerical data types in Java, Boolean and char. Two different numerical data types in Java, fixed and floating point. Two different floating point data types in Java, double and float. The double is 64-bit and the float is 32-bit. Sorry, did I say that wrong? I said it wrong. Sorry, the float is the double is 32-bit and the float is 16. Yeah, got it wrong. Sorry, confuse everyone. That's good. Very good. Ah. So the double and the float are 32 and 16. 32 and 16. Is that right? Did I get that wrong? I have to do a quick search. I thought I had that right. Let me just make sure I've got that right. For some reason, I'm having a double size in Java. Isn't it 64-bit? Primitive data types. They are 64-bit. Sorry. 64 and 32. That's what it is. 64 and 32. So I had it wrong. I did have it wrong. 32. So what did I write in here? This is going to be float. This will be long and double. Double and long. And this short is correct. Wow. Sorry about that. That never happens. Usually if I use the PowerPoints and I go on a PowerPoint death march, everybody rolls their eyes and says, why is this guy using PowerPoint? The trouble is, if I don't use the computer to type this out, if I use the blackboard where I'm used to, then no one will be able to see, and I'm trying to record it for posterity. Some people came in late, so I thought recording it would be doing them a favor. But recording errors does no one any favors. Very good. So now let's see, where are we? We've got numerical data types, and there's two of them, floating point and fixed point. And fixed point data types, we got 8, 16, 32, and 64, which we said are byte, short, int, and long. For floating point data types, we've got float and double, which are 32 and 64, respectively. What do you think of that? I could do it with a picture. It's probably easier. So, data types in Java, primitive data types. I've got numeric and I've got non-numeric. For non-numeric, I've got the Boolean and I've got the char. For numeric, I got the fixed point and I got the floating point. For the fixed point, I got 8, 16, 32, and 64, which are byte, short, int, and long. For the floating point, I've got float and double, and they are 32 and 64 bits. There we go. It's much better with a picture. Those are the different primitive data types in Java. Can you write your own primitive data type in Java? You cannot. There is no provision in the language that would enable you to do that. There are no type defs like there are in C. No type defs, which means you are stuck. If you don't like the fact that the bytes are signed and go from minus 128 to plus 127 because you want a byte that goes from 0 to 255, too bad. They don't have that in Java. Sorry. I can only tell you what they did. I can't defend it. So what that means to you, the programmer, is you're stuck. You're stuck with what they gave you. And if you don't like it, try a different language. Try C. So that's a problem. You can get around these problems, and certainly people do, but it is a basic limitation of the language. Primitive data types are not extensible. You can't add primitive data types in Java. How about comments? What's this stuff with the // What's that about? Yeah, compiler ignores it. So you can write whatever you like over here. The compiler does not care. That's called a single line comment. If you want to, you can make a what's called multi-line comment. And now you can type // just like C. If you know C, this is very familiar. Type whatever you like. As many lines as you like, as long as you terminate it with //. Have you seen that before?
Yes,
Sure.
Yes.
Yes, it's just like C. In fact, if you look at the whole thing, it looks just like C. So Java is just like C++ with a difference. And the difference is it's removed a lot of what are called the procedural artifacts from the language. Now, what about this thing called the class? What do we know about classes?
Combination of objects.
Group of objects.
They group objects?
Yeah.
Okay. How about this? A class represents knowledge. Knowledge representation. How is that? How can it be that it represents knowledge? It represents one specific kind of knowledge known as taxonomy. So it represents taxonomy knowledge, and it organizes things. It uses what's called AKO, hierarchy, or a kind of hierarchy. So when you say that you have a class, what you're really doing is you're saying you have a classification. So class is short for classification. A subclass is short for a subclassification. And just like a set has more elements in it than a subset, a class has more elements in it than a subclass. Got that? So, suppose I define for you a class of animals. Animals is a big class. A subclass is mammals. The number of mammals is clearly smaller than the number of animals. And if I said within the class of mammals there is a subclass called dolphins, the number of different kinds of dolphins is clearly smaller than the number of different kinds of mammals. So the AKO, or a kind of hierarchy, allows us to represent sets and subsets. And so when we create a subclass, it inherits properties from the superclass, that is, from the containing set.
Inheritance.
It's inheritance.
Yeah.
So subclassification, subclasses inherit from superclasses. That's the whole big secret for object orientation. That's it. And so what we do as Java programmers is we write classes and then subclasses. And within the subclasses we can have access to properties in the superclasses. Those properties can include variables, they can include methods, they can include other superclasses. They can even include some of the specifications that we can obtain by implementing what are called interfaces. What do you think of that? It's all right? No questions? We're good? So I've got this wonderful little class here called Hello. Suppose I decide to create another class. Let's call this class, let's call it Greeting. The greeting class, I'm making this up. The greeting class has a message. And I'm going to make that message a string. And I'm going to set that string equal to the hello, whoops, it's my trackpad, the hello greeting. And I'm going to give it a value, and it's called hello SW407. So that's the hello greeting. Is the string hello greeting, the hello greeting, is that string dynamic or is it static? It's dynamic. That means it exists only at runtime, right? But if you want to have access to it at compile time, you must declare it as static. So let's make it static just for fun. So that means when I compile, I'll have an identifier called greeting, which is of class type, and inside of it will be a static string called the hello greeting, whose value will be contained in the bytecodes and will be of hello 407 content. I would like to access the hello greeting. How can I do that? I'm in the hello class now. I'll go to the hello class. How can I gain access to the hello greeting?
We need class. We need to initialize the subclass.
Initialize the subclass. It's not a subclass yet. In fact, hello could be the subclass. So why not make hello a kind of greeting? Right? So if you told me that there's a parent class for the hello class, wouldn't it be hello a kind of greeting? And so we'll say extends greeting. So now the hello class is a kind of greeting, because the hello class is a subclass of the greeting class. That's nice. But it doesn't seem to do anything with the greeting class, does it? One thing I noticed about the greeting class is it has a variable called the hello greeting. So maybe instead of printing hello world, I could print the hello greeting. And now I have access to the static variable in the superclass called the hello greeting. And the hello greeting's value should be something like hello SW407. Main, public static void main, main is static. Main exists at compile time or runtime? Compile time, because it's static. The greeting class has a variable which is held as static. So that must also exist at compile time. So it's okay to reference the compile time variables from within compile time methods. It would not be okay to do that for dynamic variables. Tricky. Let's save this and make sure I haven't made any terrible mistakes by compiling. So somewhere in here I have a javac invocation. Compiles. And it says, hello, SW407. So it has access to the hello SW407 content from the superclass, because subclasses inherit properties from superclasses. What do you think of that? Yes? Good? Going too fast? No? I can go faster. So let me ask you a question. Put on your thinking caps now. What happens if I take away static? Will it compile?
No, it's a runtime as it's a dynamic.
Right? It's a compile time error because you're making reference to a dynamic variable from within a static method. The static method exists at compile time. The dynamic variable exists at runtime. So you cannot get allocation of the dynamic variable available to the subclass. So important. What does it look like when you try and compile a program like that and you have an error? I don't remember because I don't remake any errors, except now because it's deliberate. It says, aha, oh, it's a good error. Non-static variable, the hello greeting, cannot be referenced from a static context because the main method is static, the variable is dynamic.
Done.
So there's two ways I can fix this. Two ways. One way, make it static. That works good, I know that. Another way, I can instance the containing class and have access to the dynamic content. That means I have to make a new instance. In C, it's the moral equivalent of doing a memory allocation, or malloc. It costs as much. That means it has to go to the heap, grab some memory, take that memory, and instantiate, or make an instance of the class and fill that data structure. If a class is a cookie cutter, then the instance of the class is the cookie. Got that? That is, one instance of a class, just like one instance of a cookie cutter, can make many classes. Right? I can take a class and make many instances. I can take a cookie cutter and make many cookies. That's what I was trying to say. I said it wrong, but I'm trying to get there. So what I need to do, if I want to have access to the superclass's instance, is I can make either an instance of the greeting class or I can make an instance of the subclass. Which shall I do? Well, one is called has-a and the other is called is-a. Has-a means I have an instance. Is-a means I am an instance of. Right? So it is, let's assume I have a property here for pens. Pens can write. Professor Lion has a pen. That's clear. If I wanted to inherit the property from the pen in the Professor Lion class, it would strictly speaking, be incorrect to subclass the pen class in order to do it, because that would be saying Professor Lion is a pen. But Professor Lion is not a pen, right? Professor Lion has a pen. So I have an instance of a pen versus subclassing the pen, which allows me to be a kind of pen. Right? So in this particular case, we know hello is a kind of greeting, so that's okay. If I want to make an instance of the hello class, I can certainly do that. And I do it like this. Hello, H equals new hello. Now H is a variable which is an instance of the hello class. The hello class subclasses the greeting class. That means that H can be used to gain access to variables which are contained in the greeting class. So what I can do now is I can say H dot the hello greeting. Because the hello greeting is a variable which is dynamic, making a new instance of the hello class allows me access to the dynamic data structures contained both in the hello class and in its superclass. That is a way to fix the error. So now, when I save, what could possibly go wrong now? Oh, it works. Who would have thunk it? And now it works just as before. So what have I done? I've gone from static properties in a superclass to dynamic properties in a superclass. I've showed you that there are these different primitive data types, essentially two different kinds, numeric and non-numeric, two different kinds of non-numeric data types, Boolean and char, two different kinds of numeric data types, fixed point, floating point, two different kinds of floating point data types, float and double, four different kinds of fixed point data types, 8, 16, 32, and 64 byte, short, int, and long. All of the numeric data types are signed. They can be negative or positive. All of the non-numeric data types are unsigned. We've also had a little discussion about classes. Classes have what do we call it, a knowledge representation based on a kind of hierarchy, or AKO hierarchy. They represent what's known as a taxonomy. A taxonomy is a directed acyclic graph, and that's worth writing down. Directed acyclic graph. So first thing, a graph is a data structure that has many nodes and arcs. A directed graph has arrows for each one of the arcs. They go in one direction only, not both. And acyclic means that the graph does not have any branches or leaves that connect with one another. So for example, the hierarchy of all the scalar data types is an acyclic directed graph if you put arrows that is a directed acyclic graph. If you wanted to make it a cyclic graph, then you would connect these things together. Then there would be cycles. So the way it stands right now, the primitive data type tree that's shown here is a directed acyclic graph, and it can be represented directly using a class hierarchy. How's that grab you? Can someone think of another taxonomy that they may have encountered here in the real world? How about cars? You guys know about cars, right? Guys like cars. I like cars. There are different kinds of cars, right? What kind? Well, I got sports cars. I got station wagons. What would be a good way to organize the different kinds of cars that you have? It's your choice. How about convertibles and not convertibles? Or maybe sport utility vehicles and passenger vehicles, right? Different kinds of cars. And maybe you could say, well, there are vehicles that are not cars. Some go in the water, some go on the road, right? Some go in the air. So cars can be classed as one kind of vehicle, the kind that goes on the ground. But aren't there some cars that can also go in the water? The amphibious cars, right? The amphicar. You've not seen the amphicar? You've never seen the amphicar? You haven't lived if you haven't seen an amphicar. Amphicar, A-M-P-H-I car. Amphicar. Here is amphicar. Who wouldn't want a car like this? So is it a car Or is it a boat? Yes. It's a car boat. So it is possible, that you have to have two registrations when you have an amphi car. On the side you can see the numbers. That's because it's got a boat registration. In the back you can see the license plate. That's because it has a car registration. You need both kinds of registrations in order to be able to drive around in your amphi car. And look, it has propellers sticking out the back too, so it can go. Amphi cars, when they're very old, like these are, can sometimes leak, and that's very bad, because then you will sink in your car. Yeah, not good. So amphi car is it is a kind of car that is also a kind of boat. Now, what's wrong with this taxonomy? It's not a taxonomy. Why? Because it has a cycle. The car and the boat are joined. It's no good. Now, to make a car boat, to have a class called car and a class called boat, and to inherit from both, that is called multiple inheritance. The car boat has multiple inheritance. And it is a legitimate representation of reality, because there are such things as car boats. And initially, someone said, I don't think cars can float in water, and I don't think boats can drive on land. But in fact, they can. So once you see that, all of a sudden, your hierarchy, your representation of knowledge, has to change. Because now everything you know about cars is wrong. Cars can float, and boats can be driven. So now we have to sort of revise how we organize our cars. Isn't that interesting? When you study how knowledge is organized, it's called epistemology. I hope I said that right. Epistemology. And so that is the study of knowledge representation. And it is one of the things that we as programmers can struggle with when we attempt to model a business using our programs, because we're trying to model what goes on inside of the business in order to be able to represent that with our programs. A while back I said Notepad is the worst editor that I ever encountered, but I'm using it because everybody has it. But in this class, I will not be using Notepad for very much longer. Thank God. Right? Because why? Because I have something better. I have a license, which I will give to you, for using a different program, and it's called IntelliJ. And when you want to make use of IntelliJ on your system, and you'll be ready to do it within the next week or two, I'll ask you to go and download it. And what you will download, and you'll do this after you've downloaded your JDK, after you've done your first homework, is you'll download the Ultimate Edition. I'm not going to do that now because it takes a while. 264 megabytes on a wireless network. Not so fast. Once it's downloaded and ready to run, you'll have the ability to do something like this, where you have a proper integrated development environment known as IDE, or Integrated Development Environment. And what it will do is it will give you the ability to get help while you type. So for example, when you type in something like system dot, he'll give you the choices. and he can automatically fill those in. Out, dot, and now he gives you more choices. And you could say P for print. So it kind of helps you out. And if you want to, you can break up a string and hit enter, and it will automatically put in the plus sign. It will help you when you do your typing. And so it's very convenient because instead of going back to the command line interpreter, if you mouse right and hit run, it should just work. I have a malware scanner running in the background, which is slowing me down a little bit. On your machines, without the malware scanner running, it will run a little faster. So, we have about 15 minutes left. I thought we would have more questions. Are there no more questions? None at all. Did anybody happen to bring their laptop with them? No? No one brought the laptop? I'd like to... Oh, we got a couple. Does it make sense? If it's only a couple, I don't know if it makes sense to do a session. I like to do a session with the laptops. Show of hands, who does not own a laptop? Everybody owns a laptop? Got a couple. Oh, got a bunch. Ah, okay. I'm thinking about it. There may be some laptops available from the School of Engineering. They are not particularly fast. It's possible that there are loaners available, or you can bring your own laptop if you want to buy a laptop. I think they're not terribly expensive. In this particular classroom, it will get a little bit crowded unless we can spread out a bit. And if you look under the tables, I think every table has some power. So you should at least be able to plug your laptops in if you need to plug in. I myself leave the laptop plugged in all the time.
But we don't have any settings for it.
Say it again?
We don't have any connection.
There's no place to plug in under the table?
Yeah. No.
Some people have it. I can see the wires. Some have, some do not, I guess. Okay, for a final example, before I send you on your way, I thought what I would do is show you in the for loop a little program which I wrote, which allows you to have a dilation parameter called t, which ranges from 0 to 1. When you go from 0 to 1, in general, there are an infinite number of numbers which exist between 0 and 1, depending upon what your increment is, or epsilon. In my case, I have selected an epsilon of 0.01, and what I would like to do is smoothly dilate the parameter t so that it will range between a number called p0 and another number called p1. So what I will do for p0 is I will give it a number like minus 10. And for p1, I'll give it a number like plus 10. And what I'd like t to do when it ranges from 0 to 1 is output numbers that go from -10 to +10. And so now when I run this program, probably too many numbers, right? It's like 100 numbers. You can see he starts from -10 and works his way up till he's almost at +10, and then he stops. The dilation parameter is formulated so that when t is equal to 0, it's all P0. And when t is equal to 1, it's all P1. And so by using these dilation parameters between 0 and 1, I can go between any two numbers. For example, let's say I want to go from 0 to 2 times pi. And so there is 2 pi, and it starts from 0. So using these dilation parameters, you can range between any two endpoints. And those endpoints do not have to just be scalars. They can be vectors. So for example, if P0 is a color in red, green, and blue space, then you can go in this three-dimensional space through a gamut of different colors to another endpoint in red, green, and blue space. And as you traverse the red, green, and blue color gamut, you will have different colors than if you represented the color space with hue, luminance, and saturation. So if you think about what goes on inside of a television set when you adjust the color, you adjust the brightness, that's called the luminance. You adjust the saturation, and then you can adjust the hue with the tint control. So hue, luminance, and saturation is a color space that we're quite familiar with. Saturation is the intensity of the color without having the intensity of the overall brightness. So if you think about it, there are different color spaces, and the number of different color spaces that we can explore using this dilation parameter is really not limited. We can use any color space we like, depending upon what's appropriate. So the dilation parameter itself is fairly unremarkable, but the fact that we can use it to conveniently formulate a locus of points in an n-dimensional space may in fact be compelling and powerful. So all these different interesting and wonderful applications with a simple dilation parameter. So what I will do is I will leave you with that thought. I'm not going to do color dilation now. And instead, I will give you the reading assignment. Please read Chapter 1, and then do Homework 1, and then read ahead to Chapter 2. Are there any questions? No questions for me? All right, well, have a good day. Thank you.